Gravity
I
exerts
think we
a force.
just said.
Okay.
So only hand.
Gravity, force of gravity is a force.
So let's look at our,
What does normal mean?
I don't know.
Normal is the
Is pressure a physical object?
No.
Now, you know it's a physical object if you can buy it at the store or I can hit you with it. Those are like physical objects.
You can buy pressurized air.
Is pressure a physical object?
No.
Is air a physical object?
No.
Well,
I
yeah.
mean, you can buy air.
I mean,
You can hit someone with
yeah.
Can you buy air?
air. Knock the wind out.
I can hit him with air.
You can knock the wind out of someone. That's
Air is,
Yeah,
yes.
like from a concert.
Air resistance.
You ever watch
Like
Florence?
concert.
If you were a scuba diver, can you go buy air in a tank?
Oh, yeah. Yeah, but you're.
Can you buy compressed air to clean off your keyboard?
yeah.
Yeah.
Okay.
To knock the air out of someone.
I have a air shooter.
Oh, yes. Oh, I got one. Wait, it's bad. I actually had that.
Use it.
You should like go around the
What just happened?
Wait,
It hit
if it's in your face,
Did it
can you
hurt?
feel it? No. Can you do it?
Wait, it's over.
Wait, it reaches all the way.
Oh,
That's so fun. Wait, do it over here.
No,
It's funny.
I wasn't expecting
Is there
that.
a
I don't want to shoot like you're like sitting like right next to you.
Wait, do it again.
I missed. Hold
It
on.
didn't work. Crazy.
Oh.
Oh, that was a good one.
Oh, I missed her.
That's so weird.
Okay. So this is just a cute little demonstrator, but is air a physical object?
Yeah.
Okay.
where do you buy
Oh.
How many can you hit in a row?
Anywhere.
So long to get there.
I want
I
one.
did not know that.
Okay.
Where'd you get it?
DIY.
I keep throwing those.
I'm not building
Can I hit my sailboat back
Dude,
there?
I wonder what happened if you hit someone close range.
Nice.
Good job.
Yeah, what happens if you
Wait, what happens if you hit Drake?
Do it.
It's just really like violent in your face. All right, you guys with me?
Yeah.
All right.
Okay, so air is.
So air's good. What is what is the normal?
I don't know.
Why do we have dumb?
I don't know what that is. Is
Oh
the
my
hand a physical object?
Yes.
Yes.
Yeah, right? Now,
I don't know what that is. Probably.
here's where we have a problem. Okay?
He got it.
Is gravity a physical object?
No, but it is a force. Gravity is a force.
No.
What?
A force is a push or pull interaction between two physical objects.
So then there's no force on the block?
What is that?
I'm telling you.
What's that dictionary called?
What dictionary?
Webster dictionary. Say Webster dictionary.
Webster?
Definition. It says
Did the
the
Urban
approved
Dictionary say
definition
that?
that it has to be two physical objects.
Yeah, so that's a really important understanding of this. So the thing is that what will happen is if we don't have a robust definition in terms of understanding that it has to be an interaction between two physical objects,
We have to go.
Oh, are you going now?
okay? I don't know.
We have a
We have
guest
a
speaker,
guest
in
speaker in our
applied
applied med class.
med. To go along.
So if it's not between two physical objects, so here's my deal. We know that there's something pulling it down. Yes? Colloquially, you guys just call this gravity, but I don't think that's a very good way to understand it because it has to be between two physical objects. So, is there a physical object, okay, that we can say is responsible for this force? Okay? So check with your neighbor, see what your neighbor thinks. What is the physical object that is responsible for this?
Is it
Gravity? Isn't it like the moon or something?
The gravity is the Yes, it's the ground.
Gravity.
Yours is getting so long. I don't know why. I need to cover, but I don't feel like throwing it out. It's so long.
All right, you ready?
Why do you figure this out?
So, what do you think there's a physical object that's responsible for this force?
The earth.
Yeah, the earth, right? And so what we say is we say that the earth is pulling down on it. Colloquially, you would say gravity. The problem is when you say gravity, what are you talking about? Are you talking about the force? Are you talking about the free fall acceleration? Are you talking about the gravitational field strength? So we want to be specific with our language in a way that's more meaningful, so we can say, like, this is the force exerted on the block by the Earth.
Yeah.
Is that cool? So we say, well, what's pulling it down? The Earth is pulling it down. Is that cool? All right, so we're going to go with Earth instead.
Can
It's
you
no
buy
big
the
deal.
Earth?
I think that's a fine understanding. So, which way do you think the hand is pushing on the block? Up? I'm good with up. Which way do you think the Earth is pulling on the block?
Down.
Down. What is the air doing?
It's just staying.
Okay? Grace is right on this one. She says if you look at the overall force by the hand is pushing up. The Earth is pulling down.
Wouldn't it technically be the sun though, because the sun's what gives us our gravity?
Who told you that?
Science.
I don't think that's right. But since the air pushes all around, what is the net effect by all the force from the air? Zero. So what we're going to do is we're going to ignore the effects of the air unless it's windy or the object is moving fast through the air. We're going to ignore the overall effects by the air. Does that sound good?
Yeah.
Does that seem reasonable? All right, so here's how this works. Okay? We know that it's a push-pull interaction. What is the hand doing? Pushing up. So there's a force of the hand on the block. What is the Earth doing? Is it pulling or pushing? Where's the Earth?
Pulling.
It's under. So what is the Earth doing?
Pulling.
Pulling down on the block. Is that cool? All right, so here's how this works. What we're going to do is we're going to learn a new representational strategy. Nope, not purple. So this dot represents the block. And what we're, why did we leave that L? Okay. This dot represents the block, and we're going to draw the forces. What graphical construct are we going to use for forces? Arrows, why? Shows direction and the amount. You can make them longer or shorter. True? So the arrows come from the dot. The arrows come from the dot. Which way does the Earth pull?
Down.
Down.
And to label this, you say F for force, and then we're going to name the two physical objects. Earth on block. You got the first?
Don't make fun of me.
Oh my gosh. And what is the hand doing?
Pushing up.
Hand's pushing up. What do you think? Is it going to be more or less force than the Earth? Check with your neighbor. See if your neighbor knows. More or less?
He was doing more.
Equal.
And it was less.
Secret intercede is your hand. The hand on the block.
Brains.
Gravity and
More or less force.
But it's not like pulling, it'd be falling. Like if you drop it, but it's not.
What do you think? More or less?
Secret intercede.
Or the same?
The same.
Same? Why same?
Because if you were to be doing more or less, if you were to be pushing, if more pressure was applied by the hand, the block would move up, and if it was less, then the block would be going down.
You mean force, yeah.
That's what I meant.
Okay.
That's what I said.
So, and this is what happens all the time is, without a robust definition of these things, we use them interchangeably, even though they're not actually the same, like force and pressure. So let's just talk about force.
Okay.
So the current supposition is that the forces somehow are the same. Because if the hand applied more force, what would it do? It would start going up. Or if the hand applied less force, it would start going down. Is that what you guys are telling me?
Yep.
Okay. What are you 25 blocks for, man? So you want those to be the same length? Okay, that's fine, I don't care. Force of the hand on the block. So, this is our naming convention. This is how we do this. You say F because you're telling us it's a force, and then you say the object doing the pushing, and then the object that's being pushed or pulled. Sound good?
Yeah.
Does that seem reasonable? All right, let's try another one.
We just don't draw air.
Yeah, we're going to ignore the air unless the object is moving fast through the air. So there's air resistance, or it was windy.
Okay.
Okay? Because the overall forces by the air do basically balance each other out. Is that okay?
Yeah.
And they're very small anyway. They're very small anyway. Okay, next one.
You can make wonderful buses.
Got it? Can you see the block? If you would please, let's draw one of these diagrams for the block. Okay? Let's do one of these diagrams for, well actually let's do it, let's name all the things that are pushing or pulling on it. It'll be easier this way.
Oh, we're going to planetarium today? Yes. Happy Eclipse Day.
Did you say Eclipse Day?
Yeah, that's today, right? Is it not?
Remembers me.
All right, what are the things that are pulling and pushing? Work, you mean the solstice? Is that what you mean?
Caitlin! That's what I meant, Mr. Bennett.
Why are there 5?
I don't know, I just listed. Maybe there's 4. Maybe there's 10. I don't know. What are the things that are pulling and pushing on the block?
Normal.
Oh, yeah, not gravity. But his hand also, his hand's going in string. So there's 4. What was the 4th one? Earth, string, air. Oh, yeah, I remember air. Oh, now you want to sit by me.
That was explained.
Nope.
Lean all the way, Mr.
You're trying to steal answers from me.
I actually, why would I care?
It's okay, now you know how I feel, Annabelle.
Cheater.
Oh.
No, yeah, no.
Aw. You want to see my cartoon that I drew in French class yesterday?
Yeah, for the
I got you. No, just
Air high five.
don't touch it. It's pretty
Hey,
interesting.
where, how did you paint it?
I was painting.
What?
Sophia's page fell.
I don't know what you said. Did you remember?
Okay. Give me one.
Earth.
Doing what?
Earth.
Doing what?
Oh.
Pulling down.
Very nice. Earth, absolutely pulling down. That sounds very reasonable to me. Give me another one.
Hand.
And. Good, give me another one.
String.
Awesome. What else?
Air, which were
Air. So we know the air is there. We don't need to get too concerned with it. What else? Is that it?
Yeah.
Okay, so I have a question about these two. Okay.
Aren't they the same thing?
So that's a really good question. Is the earth pulling it down?
Yeah.
Yeah.
All right, so I'm going to draw my arrow, and I'm going to label it. This is the force of the earth on the block. Am I a Jedi?
I wish.
I know, right? Am I a Jedi? I mean, no, because that's not a real thing. But can I exert a force on something without touching it?
I do
Yeah,
volleyball.
the balls.
I use the force to make girls miss.
I know. How nice would it be if that were true? Right? Can you affect the motion of something? Can you put a force on something without touching it?
Yes,
What?
put a force on the block with the string.
So, I'm pulling on what? The string, and what is the string doing?
Pulling on the
So you have to be touching,
Should rephrase this question.
okay? You have to be touching in order to exert a force. So,
Mr. Paddock,
yeah.
what if you like blow a balloon or something and it moves?
What do you mean?
Like, or like anything, like a piece of paper, and you like blow at it and it'll move.
Sure. So you are putting force on the air to make it move, and then that air is putting a force on the thing.
Oh.
So you have to be touching the object to fly.
Now, there are 3 exceptions to that. There are 3 very specific exceptions. We'll talk about them later.
Okay.
But yes, you have to be touching it in order to exert a force.